Okay, we're going to skip a couple of pages on over to past composites on over to sphere so that I can be there with you when you do composite figures. So skip a few pages. A sphere is the locus of points in space that are a fixed distance from a given point called the center of the sphere. So we talked about what locus means when we did circles. We just mean if there's one single point, then this is the point that all others are around it. So they're all equidistant. Well, if I drew a good picture. So that was for circle. So now sphere is just taking that exact same concept into 3D, into space. So a sphere. A radius connects the center of the sphere to any point on the sphere. A hemisphere is half of a sphere, so all that's old information. What might be new this year is a great circle. A great circle divides the sphere into two hemispheres. So I'll just show you a picture of that over here. So here you can see a picture of the sphere, and here's the great circle. You can kind of think of the great circle like the equator of the earth. It goes around the biggest part around the center. It cuts it exactly in half. Okay, all right, so formulas, I'm just going to give you both up front. Surface area for a sphere is 4 pi r squared. So it's the formula for area of a circle, but then you actually quadruple it. And then volume is 4/3 pi r cubed. 4/3 pi r cubed. Okay, so for example 1 is pretty straightforward. Find the volume of a sphere. The only thing is they gave us the diameter as 24, so we know that means that the radius is 12 inches. And then we can just plug that into the formula. Okay, so as far as cubed goes, how you would type this in your calculator is 4/3 times 12. You're going to use the little caret button right above the divide sign to raise it to the third power. So this is 2304 pi inches cubed. Okay, try B and C by yourself. Alright, so B says find the diameter of a sphere if the volume is 36,000. I didn't finish this problem myself. So you have to set this one equal and solve back. So I set the volume equal to 36,000. First thing I did was ditch pi. Then I multiplied by the reciprocal, so I multiplied by 3/4 on both sides to get that off. So that left me r cubed over on the left and 27,000 on the right. So just like you have a square root when you have like r squared or x squared, you do have something called a cube root when you have a cubic. So I'll show you how to get to that. The easiest way is to go math, and then it's right here, number 4. That's the cube root, and then you type in 27,000. And that gives you 30. So if you didn't know that before, now you do, or you can know 30 times 30 times 30 would be the only way to get to 27,000. Okay, that gives you your radius of 30, so then that makes the diameter 60. Hemisphere, you just take the formula for volume of a sphere and you cut it in half. So instead of 4/3 pi r cubed, now we have 2/3 pi r cubed. And once you do that, then it's just a matter of plugging in 2250 pi meters cubed. Okay. Alright, example 2. A sporting goods store sells exercise balls in 2 sizes, standard with a 22-inch diameter and jumbo with a 34-inch diameter. How many times as great is the jumbo as the volume of the standard? So what we're going to do is we're going to take the jumbo and we're going to divide it by the standard. So let's just take off 4/3 pi. This would be r cubed, but we have diameter, so we need to cut that in half. And then this one would be 4/3 pi, and this would be 34. Cut in half would be 17. I just did those exactly backwards, didn't I? Whoopsies. This would be 17, and this would be 11. Okay, so then we can just plug those in and find out what's going to happen. 4/3 pi 17 cubed is 20,579.53. This one is 5,575.28. this guy divided by that guy, and we get 3.7 times as large. Okay, so I did it all the way out so that I could show you the volume here and the volume here, and then divided it out. But as you can see, when we do it all at one time, we could have just done 4/3 and 4/3, pi and pi, so then we could have just typed in 17 cubed divided by 11 cubed. So you want to read the problem and see what exactly they're asking for. If they're just asking for the difference, then you don't have to do that. You can just do this. But make sure they're not asking you for the volume individually and the difference. Then you want to do it the long way. Okay. Example 3. Find the surface area of a sphere if the diameter is 76. So remember our formula from a couple pages ago? Surface area is 4 pi r squared. So they gave me the diameter, so I'm going to want to cut that in half. So radius would be 38. And then this one's super simple. 5776 pi centimeters squared. Be very careful, you know, when you're doing surface area, it's squared, volume, it's cubed, because we're going back and forth here. Okay, try B and C. Alright, so B, I have, this one's kind of one of those two-step ones. They gave me the surface area, so I solved backwards to get a radius of 9. Then I used that 9 to get a volume of 972 pi inches cubed. Okay, kind of same story here. They gave me the area of a great circle, which an area of a circle is just pi r squared. They asked me to use that to find the surface area, which is 4 pi r squared. So I noticed between my two formulas, all I did was multiply by 4. So instead of solving the whole problem and reworking it, I just took the area of the great circle and multiplied it by 4, because this already is pi r squared. So all I needed was a 4 to complete my formula. So made it a little bit easier to get to. 196 pi miles squared. The radius of a sphere is multiplied by 3/4. Describe the effect on the surface area of a volume. So you can't, in a sphere, it's radius and only radius. You can't change one dimension and not the other. So for surface area, I would take that and I would square it. 9/16 times as large. And for volume, I would take that and I would cube it. So 27/64 times as large. And that would be your volume. Okay, so no one dimension without the other for spheres. Squared for surface area, cubed for volume. Okay, so example 5, this is our composite figure. We're going to do a whole lesson over just these, but we'll do this one together today. So what you have to remember is surface area is how much it would take to paint this or to cover it. So areas that are touching, that are overlapping, don't count. You don't count those. You have to either subtract them out or figure out whether to use lateral instead of total or what you need. For volume, it's super easy. It's just one plus the other or one minus the other, because it doesn't matter about overlapping for volume. So surface area is actually a little trickier. And one way you can work that out as to what you need is to just list out the parts. So in this one, I know I want the hemisphere. I know I want the lateral of the cylinder. And then I know I need one base on the bottom. Okay, so hemisphere on the top, the lateral around the middle, and then I need one base on the bottom. And then that can help me kind of figure out what my formula will want to be. So for hemisphere, this is going to be 2 pi r squared, because remember the formula for surface area is 4 pi r squared, so I only need half of that. Lateral of a cylinder is 2 pi r h. And then the one base, the base is a circle, so that would be pi r squared. Okay, now it's just a matter of plugging in. So 2 pi times 6 squared plus 2 pi times 6 times 9 plus pi times 6 squared. Okay, so now we can plug in and we can go here. So actually, if you look at combining like terms, this is going to be 3 times 6 squared, which this piece is going to be 108 pi, this one and that one. This one is also 2 times 6 times 9 is also 108 pi. So that's going to work out to be 216 pi inches squared. I seem to have taken up all my room with surface area. Okay, so I could have just done this all the way across. 2 times 6 squared plus 2 times 6 times 9 plus 6 squared, and then put the put the pi on it at the end. Whichever way you feel more comfortable. All right, last piece today. So for volume, it's just going to be very straightforward. I want to do the hemisphere plus the cylinder. So that's going to give me 2/3 pi r cubed plus pi r squared h. So I'm going to go sideways for this one. 2/3 pi times 6 cubed plus pi times 6 squared times 9. So I'm going to put all of this in all the way across, just omitting the pi's. So 2/3 times 6 cubed plus 6 squared, whoopsies, 6 squared times 9. And that gives me 468 pi inches cubed. Okay, so recap. For surface area, you only want the parts that you could paint. So I do not want the top base of the cylinder. I just want the hemisphere around the middle, and then I need a base on the bottom. For volume, it's everything all the way, no overlap. So I want the hemisphere and I want the cylinder. So composite figures aren't really that tricky. You just have to take them a little bit slower and make sure what pieces you want and what pieces you don't. You're using the right formulas and you're being very careful. Okay,